Hello everyone, hope you are doing well. My name is Ronak Jain. I am a final year student currently pursuing my BTech in Computer Science and Engineering at NIT Silchar. Today I will be starting a new chapter, Work Energy and Power, which is a part of class 11th physics curriculum as per the NCERT. The topic of discussion today will be Work Energy Theorem. The prerequisites to understand this topic are basic understanding of calculus and Newton's second law of motion. Before moving forward, let's start with asking ourselves what is work? We loosely use the term work in our day-to-day life, but what does it actually mean? As a people of science, for us it means scalar product of force and displacement. So what do you understand from that? Imagine you are holding a very big parcel that just got delivered and you are waiting for your mother to pay the delivery agent for the parcel while holding it. So, are you doing any work? You are holding that heavy box and by applying a certain force, but are you still doing any work? According to physics, the answer is no. Let's consider another example or another case. You are trying to push a brick wall. Will it move? Under normal cases, it won't. So, are you doing any work? The answer is still no. So, what does it actually means? Mathematically speaking, work done work done is equal to F dot dx, where F is the force applied on the object and dx is the distance by which the object is moved. This is an example where a block is moved by a distance of dx. So, moving forward, the next part is energy. Here, energy refers to kinetic energy. What do we mean by kinetic energy? Kinetic energy means a measure of work an object can do by the virtue of its motion. Mathematically, kinetic energy is equal to half mv square, where m is the mass and v is the magnitude of velocity. Until now, we have found work is equal to F dot dx and kinetic energy is equal to half mv square. The question now is, are they related in any way? Let's find out. According to Newton's second law of motion, F is equal to ma, where m represents mass and a represents acceleration. Therefore, work done is equal to F dot dx, which is equal to ma dot dx. We know acceleration is equal to change in velocity per unit time, which can be written as dv by dx by dt, which can be further written as v dv by dx, since dx by dt is equal to v. Therefore, a dot dx is equal to v dot dv, which implies work is equal to m v dot dv, since m is constant. Now, mvdv can be written as vdv cos 0 degree, as the angle between v and dv will obviously be 0 degrees, which is equal to mvdv, which is equal to mv square by 2 from v initial to v final, which can be written as half m v final square minus half m v initial square, which is equal to change in kinetic energy, since kinetic energy is equal to half m v square. So this is a very important relation, that work done is equal to change in kinetic energy. This is called the work energy theorem. Work energy theorem. Therefore, work energy theorem states that the change in kinetic energy of a body is the work done by the net force on the body. Let's understand this with an example. Let's say we have a block M, we have a block of mass M, and we wish to lift it to a height h. We have a box M, box of mass M, which we have to lift at a height h such that the initial velocity is 0 and the final velocity is also 0. We very slowly move it upwards by applying a force F on it. It's kept in under normal gravitational force, therefore there will be a gravitational acceleration applied on that box. So the question is, what is the work done by the force F? So according to work energy theorem, we can say work done is equal to change in kinetic energy. Therefore, change in kinetic energy is equal to half m v square minus half m u square, which will obviously be 0, since v is equal to 0 and u is also equal to 0. Therefore, the work done is equal to 0. Wait a minute, does that make sense to you? It doesn't make sense to me, at least. Let's check what we are doing wrong here. There is a force applied on the box F and there is a displacement as well. So why is the work done 0? Let's go back to our work energy theorem. Work energy theorem states that the change in kinetic energy of a body is the work done by the net force on the body. The key word here is net force. So I hope you understand now. Let's try moving forward by drawing an FBD of the box. There will be a gravitational force mg acting on it and there is a force F applied upwards. This is the free body diagram of our box. So the work done, the total work done is equal to work done by F plus work done by mg. Therefore, we can say, therefore, work done by F plus work done by mg is equal to 0, which can be written as work done by F plus integration of mg dot dx, which is equal to 0. Since work done is equal to F dot dx, Here the x will be from 0 to h, which implies work done by F plus mg dot dx. Now, what will be the angle between g and displacement? The force is applied in the downwards direction. The force is applied in the downwards direction. The force is being applied in the downward direction while the displacement is in the upwards direction. So, the angle between the force and displacement will be 180 degrees. Therefore, we can say g dot dx can be written as g dx cos 180 degrees. So, 0 to h g dx cos 180 degrees is equal to 0. We know cos 180 degree is equal to minus 1, which implies work done by F is equal to work done by F plus there will be a minus from cos 180 degrees as mg is a constant and x integration of dx is x, which will be from 0 to h equal to 0, since cos 180 degrees is equal to minus 1, which implies work done by F minus mg h minus 0 is equal to 0, which implies work done by F is equal to mgh. This is the final answer that we want. Summarizing, the scalar product of force and displacement is called work. Kinetic energy of an object is a measure of the work an object can do by the virtue of its motion. These are the mathematical expressions to derive work as well as kinetic energy. Now, Work Energy Theorem states that the change in kinetic energy of a body is the work done by the net force on the body. Here we should note that the force is the net force on the body. The mathematical expression for the work energy theorem is W is equal to change in kinetic energy. This was all from my side. Do let me know if you have any doubts. Thank you so much.